Hello everyone, and welcome to today's presentation. I'm excited to discuss the role of compressors in Saudi climate. Our focus will be on why selecting the right compressor is so crucial, especially in extreme ambient temperatures above 46 degrees Celsius. We'll explore how compressors circulate refrigerant, which is essentially the heart of the refrigeration cycle. As many of you know, the cooling load in Saudi Arabia is about 1.2 times higher than in other regions due to the intense heat. We'll look into key factors like efficiency, oil management, and suction pressure stability that impact compressor performance in such conditions. Throughout this presentation, we'll connect these concepts with helpful icons representing the cycle, temperature, refrigerant flow, and energy. I look forward to sharing insights that will help optimize cooling solutions here in Saudi Arabia. Let's get started. Today, I want to highlight the scroll compressor, which is often considered the hero in both residential and commercial HVAC systems. The key feature here is its design, two interleaved spiral scrolls, with one orbiting the other. This unique design allows for smooth, quiet operation and high efficiency. When it comes to calculating capacity, we use a simple formula. Capacity in kilowatts equals the mass flow rate times the difference in enthalpy between the inlet and outlet, divided by 3600. This helps us size systems accurately. For example, a typical 4-ton split air conditioner, which is roughly 14 kilowatts, uses this calculation to ensure it meets the cooling demand. The refrigerants most commonly used are R410A and R32, both known for their efficiency and lower environmental impact. The oil used in these compressors is POE 68 or 100, which provides good lubrication and performance. In terms of pressures, the typical suction pressure is around 120 psi, while the discharge pressure is approximately 360 psi. These pressures are crucial for efficient compressor operation. Finally, I want to point out some icons that highlight the benefits of scroll compressors. They offer high efficiency, low maintenance, and quiet operation, making them a reliable choice for many applications. Overall, their innovative design and operational advantages help us deliver better comfort and energy savings. Let's take a closer look at the rotary compressor, which is known for being both compact and economical. Its design features an eccentric roller inside a cylinder, which helps keep the unit small while maintaining efficiency. This type of compressor is particularly well suited for window air conditioning units and mini-split systems that are under 3 tons, making it ideal for residential or small commercial applications. When it comes to efficiency, there's a specific formula to understand the volumetric efficiency, or ETA letter 1D65, of this compressor. It's calculated as 1 minus a constant multiplied by the pressure ratio raised to a power. This helps us gauge how well the compressor performs under different conditions. In terms of refrigerants, the rotary compressor can work with common options like R22 and R410A as, for lubricants, mineral oil or POE 68 are typically used, depending on the specific refrigerant and application. Now, looking at the icons, you'll notice that this compressor is low cost, which makes it attractive for budget-conscious designs. Its simple design also means easier maintenance and manufacturing. And while it does produce moderate noise levels, it remains a popular choice because of these advantages. Overall, the rotary compressor strikes a good balance between cost, simplicity, and performance, fitting well into the theme of efficient, practical HVAC solutions. Let's talk about screw compressors, which are truly the industrial powerhouses behind many large-scale cooling systems. They use 2 helical rotors, one male and one female, that work together to compress the refrigerant. This design is highly efficient and reliable for continuous operation. When calculating their capacity, we look at the displacement, essentially, how much refrigerant they can move, and multiply that by the volumetric efficiency. For example, a common model like the Bitzer CSH 9583140Y is used in York YVAA chillers with around 400 tons of refrigeration. As for the refrigerants, these compressors typically run on R1340 or R1234Z, with PAG 68 oil to keep everything lubricated smoothly. The operating pressures are also important. Suction pressure is usually around 60 psi, while discharge pressure can reach about 180 psi. These compressors are ideal for large buildings, offering continuous operation and high capacity, making them essential for big-scale cooling needs. Their robust design and efficiency help ensure reliable performance in demanding environments. Let's take a closer look at the reciprocating compressor, specifically the legacy and service units. These compressors work on a classic design that combines a crankshaft and a piston inside a cylinder, which can be either hermetic or semi-hermetic. This design has been reliable and well understood over the years. In terms of the fundamental principles, the operation is based on the ideal gas law, PV equals MRT, which relates pressure, volume, and temperature. When it comes to cooling capacity, we often look at the heat transfer equation. Q equals the mass flow rate times the change in enthalpy, or letter 1E41 times H2 minus H1. This helps us understand how much heat is being moved during compression. These compressors are typically used in applications like cold rooms and medium-sized chillers, where reliable, steady cooling is essential. As for refrigerants, R404A and R22 are common choices, depending on regulations and system requirements. They are compatible with mineral or POE 100 oils, which help maintain proper lubrication and efficiency. Now, looking at the icons on the slide, you'll notice that these units are repairable, which means maintenance or part replacement can be managed effectively. They operate under high pressure, so safety and robustness are key, as indicated by the rugged design icon. This combination of features makes reciprocating compressors a versatile and dependable choice for medium-scale cooling needs. Let's take a closer look at hermetic versus semi-hermetic designs. Hermetic systems have the motor completely sealed inside a shell, which makes them very compact and also quite quiet. This sealing helps protect the motor from external contaminants and reduces noise levels. On the other hand, semi-hermetic designs feature a bolted housing, which means they can be opened and serviced on site. This makes them more accessible for maintenance and repairs when needed. Now, if we look at the application table, you'll notice that scroll compressors are typically hermetic, indicated by the locked icon, emphasizing their sealed nature. Screw compressors tend to be semi-hermetic or open drive, which is shown by the nut and bolt icon, highlighting their serviceability. The icons here are helpful. The locked symbol reminds us of the sealed, maintenance-free aspect of hermetic designs, while nut and bolt and toolbox point to the serviceable and maintainable qualities of semi-hermetic units. Understanding these differences is crucial when selecting the right compressor for an application, especially considering factors like noise, accessibility, and maintenance needs. This choice directly ties into the overall theme of optimizing system efficiency and reliability. Let's walk through the key steps for installation and commissioning. First, it's essential to mount the equipment on a vibration-isolated base. This helps reduce any noise and prevents issues caused by vibrations during operation. Next, we connect the suction and discharge lines using flexible hoses. This flexibility makes the connections easier and ensures a secure fit. After that, we need to evacuate the system to about minus 750 mmHg. This step removes any air and moisture, which is crucial for optimal performance and longevity of the system. Once the system is evacuated, we charge the refrigerant using the superheat method. This approach helps us ensure the right amount of refrigerant is added, optimizing efficiency. Then, it's important to verify the phase rotation to make sure the compressor runs correctly, and check the oil level according to the 3GS standard. Proper oil level is vital for the compressor's health and smooth operation. Throughout this process, safety is paramount, so always keep safety icons in mind, like for safety precautions, high voltage for electrical connections, droplet for oil checks, bar chart for pressure testing, and white heavy checkmark for the final run. Following these steps thoroughly will help ensure a successful installation and reliable operation of the system. Now, let's talk about operation and maintenance best practices. First, on a weekly basis, it's crucial to record key parameters like amps, pressures, and superheat. These measurements help us monitor system performance and catch any irregularities early. Then, every month, we should check the oil color and vibration levels. These are good indicators of equipment health. And once a year, it's important to inspect the motor windings and replace the oil if needed, to keep everything running smoothly. In addition to routine checks, preventive tips are vital. Avoid liquid slugging, which can cause serious damage, and always keep air filters clean to ensure proper airflow. Maintaining phase balance within plus or minus 2% is also key to efficiency and longevity. Remember, using a log sheet clipboard helps track these activities, while training brain keeps everyone sharp. Preventive care hammer ensures reliability, and focusing on efficiency gear can save energy costs. Finally, paying attention to the entire life cycle counterclockwise, arrow's button of the equipment, helps optimize performance over time. All these practices come together to support a well-maintained, efficient system that lasts longer and performs better.